Hello everyone, I am Nisarga. Our topic is static memories, dynamic RAM, asynchronous dynamic RAM, and synchronous dynamic RAM. Team members are Rakshita, Kusuma, and Priya. SRAM is defined as static random access memory. SRAM is a type of semiconductor memory used to store data temporarily in digital systems. Static memories overview. Static memories retain their stored data as long as power is applied. Implemented using latch-based cells that do not need periodic refresh like dynamic RAM. SRAM cell structure. A typical SRAM cell uses a latch connected to bit lines through access transistors controlled by a word line. The latch can be in one of two stable states representing logic 0 or logic 1. This is representation of SRAM. B and B dash are bit lines. T1 and T2 are transistor inverters. X and Y are internal storage nodes. Word line controls T1 and T2. SRAM read operation. To read the word line is activated to connect the latch to the bit lines. The state of the latch 0 or 1 is sensed from the bit lines by sense or write circuits which generate circuits output. SRAM write operation. To write the appropriate value and its computant are driven onto the bit lines. Activating the word line forces the latch into the new state corresponding to the data on the bit lines. Next will be continued by Rakshita.
Hello everyone, my name is Rakshita. I'm going to explain about the topic synchronous DRAM. In SDRAM, all operations are synchronized to an external clock signal. The organization is similar to asynchronous DRAM but with added control logic and registers for pipelined transfers. SDRAM block diagram explanation. First one is main blocks, row, column, address, decoders, control logic, cell array, read or write control, and data input output registers. It commands through RAS, CAS, WECS, and clock control the mode, register, and timing of memory operations. SD-RAM operation highlights. Row and column address are registered, enabling faster and more predictable access times. Burst transfers allow consecutive locations to be read or written efficiently once a row is activated. Next will be continued by Priya.
Asynchronous DRAM, double data rate SDRM transfers the data on the both rising and falling edges of the clock, efficiently doubling bandwidth for the long bursts, particularly useful when the sustained block transfers are required between the memory and the processor or the graphical units. Meaning of the asynchronous operation. In the asynchronous DRAM or the SRAM, read and write cycles are initiated by the changes on the address and control lines, such as the chip enable, output enable, and the write enable, not by the clock edges. The response time is specified as in the access time, for example, 60 to 70 nanoseconds. So the processor must wait until the interval has elapsed before the valid data is guaranteed.
ಅಪ್ಪ ನೀನು ಜ್ವರ ಬಂದ
Asynchronous DRM features. Early DRM chips used this asynchronous interface with separate row and the column address pins, bidirectional data pins, and the explicit RAS or the CAS control signals. These, these memories require the periodic external refresh cycles to preserve the data, and they typically support the page or the fast page modes that speed up a sequence of the accesses within the open row. This is the asynchronous DRM diagram. RA stands for the row address stop and CA stands for the column address stop. Row address latches, it sends the data to the row decoder. Next will be in the row decoder, it decodes the data and sends to the cell array. In the column address latches, it sends the data to the column decoder. column decoder connects the sense or the right operations, and the data will be given to the column decoder in the type of the D1, and uh, in the column decoder sends the data out to the D0, and CSC stands for the chip select, and the RW are the read and the write operations. Thank you. Next will be continued by Kusma.
Comparison with synchronous STRAM. Synchronous DR, DRAM allows all components and data transfer to the system clock and uses internal pipelines and burst mode to active much higher effective bandwidth. Asynchronous DRAM is simpler and cheaper but offers lower data transfer rates and more variable latency, so it is mainly found in older low performance system, whereas the STRAM and DDR STRM dominates modern main memory. Conclusion: the evolution from simple static memory to clocked STRAM and DDR has greatly increases the memory bandwidth and made large higher speed main memories practical. ST, SRAM remains valuable where the fastest possible access is needed, such as a Kaker well STRAM and DDR. STRM dominates main memory because they balance density, speed, and cost. Under understanding their types, their operations, and their typical applications provides a solid and functional for study more advanced memory, hierarchical, and performance optimizations. Thank you.